Hi everybody, Mike Ball here. Today we're going to talk about the refrigeration cycle. Sounds like fun? It is. Let's get started. On my first day of refrigeration training many years ago, our instructor informed us that we would never truly understand the process of refrigeration until we understood that there is no such thing as cold. There is only more heat and less heat. I remember thinking that he had never shoveled snow from the driveway in December. If you think about it though, there is no way to measure cold. That cold day in December could be 12 degrees Fahrenheit, but it's still a measure of heat, not cold. Refrigeration is the process of moving heat from one location to another. In residential air conditioning, we move the heat from an uncomfortably warm house outside, leaving the temperature inside at a pleasant 72 degrees. For practical purposes, we can still use the term cold to describe things as long as we realize in the world of physics there is only more heat and less heat. The refrigeration cycle is just that, a cycle. Like all cycles or circles, there is no place to call the beginning or the end, so we must choose a spot and go from there. Where to begin? Now let's start in the house. In the air handling closet, there is a coil that looks like a car's radiator. It is filled with a refrigerant that is very cold. That is, it has very little heat. When the blower blows warm air from the house across the coil, it absorbs the heat from the air. The refrigerant is always moving as long as the compressor is running, so the refrigerant, now slightly warmer, heads to the outside to the compressor. The compressor takes this refrigerant and compresses it into a much smaller space, where it turns from a warm gas into a very hot gas. All of the heat from the inside of the house is now compressed, and the tubing becomes very hot to the touch. The hot gas is pumped to another coil called a condenser. It has aluminum fins for ease of heat removal and a powerful fan to blow the outside air across the coil. We've all tested the air blowing out of the condenser by holding our hand over the unit, where we notice that the air coming out is much warmer than the outside ambient temperature. It's at this stage where the heat from the inside of the house is sent to the outside air. The refrigerant condenses from a hot gas to a warm liquid. It helps to think of a cold soda can. The air around the soda can condenses into droplets of water on the side of the can. This is what is happening on the inside of the condenser. The liquid refrigerant is pumped back into the house and is sprayed into the evaporator coil where the tubing is much larger. This gives the liquid room to expand into a gas. What happens to the temperature when a liquid evaporates into a gas? That's right, it gets cold. It helps at this point to imagine spraying an aerosol can like an air freshener or a pressurized window cleaner. The can feels much colder to the touch than before you started spraying. The refrigerant has given up its heat and is now ready to absorb more heat from the inside of the house, right back where we began. No matter what type of application we have, air conditioners, refrigerators, freezers, it's always the same process. Heat is pumped from one location to another location. In the winter, some climate control systems also use this process in reverse, where it takes heat from the outside air and pumps it into the inside living space. These units are called heat pumps. The overall cost of running a heat pump is less than an electric heating system because the electric heating system must create its own heat by using power. If your area has natural gas available, the cost of gas heat is even less than the heat pump because of the available energy that is already inside the gas. Industrial refrigeration systems are used in a wide variety of applications, primarily to preserve perishable goods, control temperatures and sensitive processes, maintain efficient cooling systems. These systems are critical in industries like food and beverage, pharmaceuticals, and even data centers. And that's all the time we have for this lesson today. We'll see you next time. Thanks for watching.